Okay, guys, we're going to be continuing with the law of sines today. We're going to add a new component to the law of sines. You're not learning anything new as far as how to do the law of sines. I think you guys are probably okay with that. But what's happening now is we have what's called the ambiguous case of the law of sines. Now, that will not affect anything you've learned. It just adds something to it. First of all, let's talk about when this can happen. First of all, you can only get this ambiguous case when you're doing the law of sines to find an angle as the very first step, which means if I give you, say, two angles and a side, and you do the law of sines to find a side, it's impossible to have what's called the ambiguous case. So the scenario has to be law of sines, and you have to be finding an angle like right off the bat. Now, what's up with the ambiguous case is what happens is, and like I said, it doesn't affect how you do the problem, but what can happen is you can end up happening two different sets of solutions. So you would do the problem normally like you've been doing it, and I would give you three like down here, and you would find the three you were missing. Problem is there's also going to be three other answers that also work. So an entirely different triangle with these three originals, but three other answers. That's going to happen with the ambiguous case. Or you could get no solution. Now that's an easy one. No solution means that you put it in your calculator, whatever you were trying to solve for, the angle, and you got an error, probably a domain error. And that means what's happening there is the measurements of the triangles, that's not even possible to have a triangle with those measurements. And that, again, that scenario can only happen if you're doing the law of sines to find an angle as the very first step. Now, make sure it is you're finding an angle. If you're finding a side and you get a no solution, you did something wrong. Like, that's not, no solution. That you made a mistake. All right, let's take a look at this problem I got down here. So this is set up as normal law of sines. Some of you guys, when I was looking at your homework last week, you did not draw the triangle. I want the triangle drawn for every single problem, labeled with all the things I give you and all the things you find in there. So angle C is 22, that goes here. Little a is side A, which is across from angle A, that's 10. And little c is across from big C, that's 7.5. So it's definitely a law of sines problem because you have big C and little c. Like, that's what you have to do the law of sines. When we do the law of cosines, you won't have that. You might have, these two, and then you'll have little b, where you don't know an angle and the side like you do here. But since I do here, we're going to go ahead and do the problem just as if it were last week. So I can say the sine of angle C, 22, over little c, 7.5, equals the sine of, since I have little a, all I can do is find big A, over little a is 10. So this is nothing, like I said, different than last week. You're going to cross multiply. It's going to be an inverse problem because you're finding an angle, and none of that's changing. Now, I don't know if you guys realize this yet, but when you're finding an angle here, you don't have to cross multiply. You could just multiply both sides by 10 to cancel this 10 out, which is what I'm going to do. So this 10 is going to go up here in front. So it's 10 times the sine of 22 over 7.5 equals the sine of angle A. And now I'm going to do inverse, which means this guy goes in front there as the inverse. And normally we would just go to the calculator right now. Angle A is going to be equal to inverse sine of this guy. 10 sine of 22 over 7.5. Now, normally, you guys would just go to the calculator and find angle A. I'm going to show you something a little bit different. Now, you're not going to do anything like this, but it'll help you understand what the ambiguous case is all about. So what I'm going to do instead is I'm going to put this in my calculator without the inverse. I want to know what that is. So I'm going to say 10 times the sine of 22 divided by 7 point, oh, I didn't end the parentheses. 10 times the sine of 22 divided by 7.5. All right, so 0.499, a bunch of change. Now, we're not going, I don't ever want you to do this because I don't want you to round in the middle of the problem and get the angle wrong because you rounded in the middle. But for the purpose of the lesson, I'm going to, so I can show you something that I know you already know. So this is about 0.5. I mean, it's pretty close as we're going to get. So I'm going to put a 0.5 here. So the sine, inverse sine of 0.5 equals angle A. All right, now I want you to think about what I'm asking to find here. I'm asking you to find the angle whose sine is 0.5, because inverse sine is just a button we use to find an angle. So what I'm really doing is, at this point, I'm going to my unit circle, and I'm going to find where sine is 0.5, which is a half. Here's our unit circle. Right there at 30 degrees is where sine is equal to 1/2. So if I put this in my calculator right now, this whole thing, angle A is going to come out to be 30 degrees. So I'm just going to do inverse sine of that answer. And notice you get 30 degrees. 29.96, but close enough. Angle A equals 30 degrees. And again, that should make sense to you because that's where sine is 0.5. 0.5 is a half. Here's the problem with the ambiguous case. This is what it's all about right now. 30 degrees is where sine is equal to 1/2. But the problem is, there's a quadrant 2 angle also where sine is 1/2, 150. Which means that angle right there is not the only answer. And that's what the ambiguous case is all about. You're going to always have, if you find an angle as your very first step, there is always going to be a second angle, the quadrant 2 angle. So angle A is also a 150 degree angle. So that's what you're going to have to do. You're going to have to find the angle that's equivalent in quadrant 2. So this is quadrant 1's angle, where sine is 1/2, and this is quadrant 2's. Your calculator does not have the ability to give you a quadrant 2 angle, an obtuse angle, ever. It will always only give you this one. So what you're going to have to do is you're going to have to calculate this one every time by saying 180 degrees minus whatever the angle is you find. So if that's a 20 degree angle, this will be 160. If that's a 50 degree angle, this would be 130. These are supplementary angles. They always have to equal 180. This is the quadrant 2 version of a 30 degree angle. But it won't always be something from your unit circle. So this is, you're going to have to know this. This is how you do to find the second angle. All right, so here's the deal. You got to decide right now whether or not this angle is usable. So now, let me zoom out a little bit and go to the whole problem. I'm going to put this 30 degrees in here because that's the answer for angle A. That's fine. I'm going to subtract these from 180, and I'm going to get this angle just like you guys have been doing. So there's nothing new you're going to do with the very first angle you find. You put it in there, you business as usual. So I got 180. I'm going to subtract away this 30, subtract away this 22, and this top angle is 128. And then I'm going to do law of sines again, and I'm going to find little b, which I'll do that in a minute. What the problem with this